There are some great applications of the derivative specific to business and economics, and that's going to be the focus of this next set of videos. We're going to start out with looking at what is called a marginal analysis. When we're talking about marginal, we're talking about the impact of one more. And that marginal can refer to lots of different things, but the three main things that we see them on with economics is marginal cost, which is the cost to produce one more. Marginal cost you'll see represented with MC of x for marginal cost. But what that really means is we just take the cost function and we take the derivative to see how fast it is changing at that instantaneous point. Another place you'll see marginal is with marginal revenue. And that is the revenue created by selling one more. And you'll see MR of x for marginal revenue. That's just the revenue's derivative, or how fast the revenue is changing at that point. Finally, the last one is the marginal profit. And that is the profit from producing and selling one more. Or how fast is the profit changing at that point? Now, we know that the profit is equal to the revenue minus the cost. How much money you brought in, subtract how much money went out. And so if we took the derivative of both sides of this equation, we would end up with the derivative of the profit is equal to the derivative of the revenue minus the derivative of the cost. Or kind of in the general marginal terms, the marginal profit is equal to the marginal revenue minus the marginal cost. You'll see all three of these written out as useful formulas working with marginal analysis. So let's suppose that revenue is given by R of x equals negative 3x squared plus 800x. We're going to find the marginal revenue for 20 items. In other words, if I'm selling 20 items, then I want to know what happens if I sell one more. How much more revenue do I get? Well, the way we get that is from the marginal revenue formula to see how fast the revenue is changing. Remember, marginal revenue is equal to the derivative of the revenue, which we can do the derivative using the power rule very quickly here to get negative 6x plus 800. And we want to know what's happening specifically at 20 items. So we'll stick the number 20 in for the x and get negative 6 times 20 plus 800. Or negative 120 plus 800, which is going to be $680. So the impact of one more at the point of 20 items is about $680. Let's say, suppose cost is given by the cost function. C of x is equal to 0.004x squared plus 10x plus 8,000. And we want to find the marginal cost for 1,000 items. So we're selling 1,000 items right now. How fast would that cost change if we increased by 1? That is the marginal cost function, which is just the derivative of the cost function. Power rule makes this really easy. It's going to be 0.008x plus 10. And we want to know what's happening specifically when we're selling or producing 1,000 items. We want to stick 1,000 into the cost function. So we have 0.008 times 1,000 plus 10. That's just going to be 8 plus 10, giving us a marginal cost. The cost to produce one more item, the cost is changing at a rate of about $18 per item at the point of 1,000 items. That is the marginal analysis. Marginal is just the derivative at the point. Our next video is going to take a look at another application in economics called inventory cost.